go. Before we get into our shortcuts and our special right triangles, let's just do a couple practice problems here to warm it up. Let's just review our square root knowledge. Now remember, no mixing and matching, meaning you can't multiply a 6 and a 2 together. One's in a root, one is not. You can only do the root numbers together. I'm going to leave 6. What's 2 times 2? 4. Now, most of you can probably do a final answer in your head. We don't need a calculator. What's the square root of 4?
2
times 6. 12. There we go. We got it. 2 times 6. Piece of cake. Okay, rationalizing. That sounds so fancy. Rationalizing the denominator. You cannot have a square root in the denominator, so remember we have to put another square root on it. And whatever we do to the bottom, we have to do to the top. So, of course, on the top, we can't multiply 6 and 3 together. One's under a root, one is not. Okay, most of you I know can do the bottom in your head. Because 3 times 3, 9. What is the square root of 9?
3.
Got it. Now, before I circle this, is there anything you could reduce? The 6 and the 3. We can just do that in our head. What's 6 over 3? 2. Yeah. So again, you're going to keep seeing, they just keep coming up this chapter, you're going to keep seeing the square roots, the rationalizing, all this stuff. Okay, determine if the triangles are right, acute, or obtuse. So we are testing them in Pythagorean theorem. On number 3, first question for you. What is the biggest side? 2, square root of 5, or 3? 3. If you punch square root of 5 in your calculator, if you're not sure, it is smaller. It's a decimal. It's 2 point something. So this is our biggest side. Now, again, we're testing the triangle. It doesn't matter which is A, which is B. I'm going to go A is 2, B is root 5. You can have them switched. So I'm going to test A squared, B squared. I'm not going to put an equal to because I don't know if they're equal. We're going to test it here. And then 3 squared. Okay, let's do some math. We all know 2 squared. What happens when you square and a square root? What do they do to each other? Cancel their inverse operations. Fancy vocab for you. 3 squared. So you've got 9 and 9. What type of triangle is that? Right, when they equal the same. Love this stuff. I probably have more work than you do, as always. You know how it goes. Okay, let's look at 4. What is the biggest side? 16. If you're not sure, I punched that in my calculator earlier because I was like, even just looking at it, I was like, ooh, they're kind of similar. This is about 13.4. So that's not going to be our biggest side, but I did check because I didn't trust myself. Okay, biggest side. I'm going to do this one A, this one B. So I'm going to use the square root, though, because we want to use the exact number. Plus B squared, C squared. Can't. My board is being a pain today. Okay, let's test it. Square root, square, and cancel, got it. 9 squared, I know it. 16 squared, you probably need a calculator for. What's 16 squared? 256. All right, and what did you get when you did 179 plus 81?
216.
So not right, because they're not the same. So now decide for me, acute or obtuse? Acute. Because remember, it's all off of your C squared. C squared smaller, acute. And I mean, let's get serious. Look at the triangle. Doesn't it kind of look like it's acute and not obtuse? kind of does, you know. Right. Okay, so I love Pythagorean theorem. You love Pythagorean theorem. But it is a little time consuming. So there are some shortcuts that you can use on special cases. That's what we're going to show you today. This is what we're going to get into on our 45, 45, 90, 30, 60, 90 triangles. So first thing we're going to talk today, 45, 45, 90. So an isosceles, good vocab, 2 congruent sides. Isosceles right triangle can be formed by cutting a square in half as shown. So you have to fill in on the blanks. Isosceles, we should have a spelling test over that. Right. Formed by cutting a square in half. So obviously we're not going to focus on a full-on square. We're on the triangles. So if I just focus in on, let's say, this guy. So of course, if you're going to cut this in half, these are your 45s. Now, you know my love of vocabulary. I probably have way more of a love of vocabulary than you do, okay? If you have 2 congruent angles, 2 congruent sides. So over here on the board where I have the triangle picture, my 2 45s mean I have 2 congruent sides on it. That is that, if you remember, base angle theorem. Does that sound at all familiar from first semester? So the nice thing on these, this is why it's a shortcut. If I know one of the sides, I automatically know the other. I don't have to do Pythagorean theorem today. And there's going to be a shortcut to get your hypotenuse, which is the next thing I'm going to show you. So to get your hypotenuse, so in a 45-45 triangle, the hypotenuse is the square root of 2 times a leg. So this is what you're going to fill in. So the leg, which remember is your fancy name for one of the sides, so you're going to take a side times a leg. So here's why I love these. I can look at it, I can do it in my head. For instance, if I told you this side is 10, well, I know this one's 10, I know this one then is 10 root 2, and I'm done. Okay? That's as crazy as they're going to be today. Now, we might have to do a little radical simplifying, of course, that always comes into play, just for the record. Now, we're going to start easy. We're not going to do anything crazy, but, you know, dramatic emphasis here. Remember, it says leg times the square root. If I have to do the opposite, if I give you the hypotenuse and I need the leg, just think about this, because this is going to come into play. What's the inverse operation of multiplication? Division. So I might have to divide later on when I have to go from the hypotenuse to a leg. So just think about that. And of course, we're doing exact answers. We're not giving decimals, etc. I love these problems. Find the legs of the missing sides. Okay, so I know 45. I know this is going to be 45. Because also don't forget, all three angles in a triangle always add to how many degrees? 180. So 45, 45, 90, 90, 180. Okay, two congruent angles, two congruent sides. I know that one's 5. Winning. And then to get the hypotenuse, it's just the leg, 5, times root 2. And I'm done. And you can see I don't do anything fancy. I mean, I have some kids that like to write in the back, see? And you're welcome to do that. Okay, I just label them on the triangle and make my life easy, which you can too. Okay, so obviously 45, 45, 90. Two congruent angles, two congruent sides. And then I don't have to do any work. I know the hypotenuse, 6 square roots of 2. A leg times a root 2. You scroll it over. Same thing, 45, 45, 90. Two congruent angles, two congruent sides. So I know this is 3. No work needed. What's your hypotenuse? 3 square roots of 2. Done. Love it. I could do this all day, right? All day. Now, you know how it goes. Those were easy. These are still easy, but we got to get a little fancy here and do a little maybe more calculations with our radicals. Same thing though. 45. We know it's 45 now. We don't have to keep writing it. We know these are going to be the same. So I'm just going to put this side as 2 square roots of 2. Now, hypotenuse. It's still the same process, but I'm going to do a little more simplifying now. Remember, your hypotenuse is one of the sides. It's going to get crazy here. Times the square root of 2. Okay. So it's still the same thing I was just doing. You just got to simplify all of this a little bit. So square root of 2 is square root of 2, square root of 4, and then a little mental math here. What's the square root of 4? 2. Times the 2 in the front for a final answer of 4. That's a sloppy 4. So you're just a little more simplifying you're going to have to do now. We can't do all easy numbers all the time, right? Okay, 45, 45, 90. So 2 congruent sides. So I know y is 4 root 2. I can just fill that one in. That's the easy one, obviously. Okay, hypotenuse is this leg times a square root of 2. Now, some of you I know are getting good at this and can probably do that all in your head and just write down the answer. More power to you. I don't care. Square root of 2, square root of 2. I'm going to multiply those square root of 4. So what's your best, easiest, simplest answer for 4 square roots of 4? 8. Because you have 4 times 2, really. Got it. Any questions on that? So it's the same as the front. We're just doing more radical work. We're going to do some more because these are the trickier ones, right? Okay, so 45, 45, 90, 2 congruent sides. So of course I know y is the square root of 2. to get your hypotenuse, remember hypotenuse across the right angle, is one of the legs times the square root of 2. A lot of you can just do that right in your head. You have the square root of, what's 2 times 2? And what's the square root of 4? 2. I need longer arms so I can reach. Got it. All right. Ooh, fraction. Ooh, fraction. Don't want to scare you. It's the same thing. 45, 45, 92 congruent sides. So I know this one is square root of 10 over 2. That's the easy one. Okay, I might run out of room to do the hypotenuse up here, so I'm just going to, I got all this from underneath. I'm going to do it underneath. So remember, the hypotenuse, okay, is the leg, which is this very lovely fraction, times the square root of 2. Okay, well, let's simplify it. We can do it. So I'm going to multiply your square roots together. What's 10 times 2? 20. And then, of course, my denominator, you just have the 2. Now, this is like the never-ending problem. Can we simplify the square root of 20? Yeah, okay. So now you're either, remember, it's your choice how you simplify. Either making the factor tree or you're thinking about your perfect squares. I don't care which way you do it. I see it's kind of a mixture in here. I think most of you are going factor tree. So I'm going to factor tree it real quick. Well, let's go 4 times 5. And then 4 I can break down some more. So there we go. I've got my pair of numbers. So that pair of numbers, I'm going to have a 2 out front. My poor single 5 is stuck underneath. And we're still going. We're still going. Because what can you cancel out? The 2's. Whew, I did a lot of work, a whole lot of work to get a hypotenuse of the square root of 5. Now again, the geometry part was easy. Congruent, times the square root of 2. This one just got ugly because we had the fraction, the radical, the simplifying, all the algebra in it. They're not all that bad, trust me. Okay, here we go. A little different here. So 45, 45, 92 congruent sides. Now, this time we're going opposite. They gave you the hypotenuse. You were finding the 2 congruent legs. So this time I am not timesing by the square root of 2. You have to do what? What's the opposite of times? Divide. So some of you, again, could do this one in your head. You know I love to write work. So we're going to do the hypotenuse divided by the square root of 2. Now, that comes out nice. You're just left with what? 8. So my sides are 8. 8. So when they give you the hypotenuse, you are dividing. Now again, some of you can just look at this and do it in your head. You know I love to write work. We're going to do our hypotenuse divided. So what are your sides? 5. My 2 congruent sides, 5 and 5. And some of you could have just looked at that and figured it out with no work. Okay, same thing. My 2 congruent sides we're after. I should say legs, okay? So hypotenuse 8. Again, we're dividing. And now I'm cringing. Can you have a radical in the bottom? No, we have to rationalize the denominator. Okay, I'm going to do it. All right, so of course on the top I have 8 square roots of 2. What's 2 times 2? 4. So you have, let's mental math it. What's the square root of 4? 2. And then what else can you reduce? 8 and 2. So my congruent legs, what's 8 over 2? My congruent legs are 4 square roots of 2. So still easy, but these can just get a little dicey if you have to maybe rationalize or simplify a radical. Do the radical words. That's where it gets challenging. Okay, now it is a free-for-all. Anything, everything can happen. I'm going to give you a few minutes to try them first. Let's see how they're going. And then, of course, I'll go over them with you. Let me give you a few minutes first. I'm going to do them out of order, okay? I gave you the hint. I said 3 is the easiest one. So I'm going to start with 3. Okay, so of course 45, 45, and 92 congruent sides. Obviously this one's 3. No work needed. What's the hypotenuse? Love it. So I almost feel awkward saying this. This is an assignment where some of the problems I can't yell at you about showing work. Because was there any work to show on that one? Sure wasn't. I don't like it at all, but it is what it is. Okay, let's just go in order, I guess. So of course, two congruent sides. So I know this one's 4 root 5. That's easy. Now, I do have to do a little bit of work for the hypotenuse, okay? I'm going to have to do some radical work. For hypotenuse, of course, I don't know if I can sneak it in there. So it's one of our legs times what? Square root of 2. So you're going to end up with 4 square roots of 10. Now, quick question as always. Can you simplify the square root of 10? No, because if I factor tree it, you're going to have 2 and what? 5. You won't have a pair of numbers. So I'm just going to circle it. Done. So there's my hypotenuse. Just going to draw an arrow. That's what it is. All right, let's look at this one. Now, 2 congruent legs. This time they gave you the hypotenuse, the 7. So I'm not timesing by the square root of 2. You have to what? Divide. So I'm going to do 7 divided by. And then we cringe a little bit because we know we can't have that radical, so we're going to rationalize. Okay, some of you can probably do that right in your head now. So our congruent sides are going to be 7 square roots of 2 on the top. What do you get on the bottom? 2. Square root of 4, 2. I'm just going to arrow that same thing because I don't feel like writing it twice. All right, final one, 4. Again, 2 congruent sides. So same thing as the one right above it. They give you the hypotenuse, so we're not timesing by the square root of 2. You're dividing. Now, don't let that scare you. Same process. We have to rationalize the denominator. So you're putting the 2 on still, square root of 2. Okay, so on top I hear you've got the square root of 6. What do you have on the bottom? 2. Square root of 4, which is 2. Can you reduce square root of 6 and the 2? Can you do the 6 and 2? Nope, because one's under root, one's not. I'm just going to put it over here too, because they're the same. So, and of course, I don't care if you just label on the picture like I do. Some kids will do like this. X, Y, they're the same. Root 6 over 2. However you want to put your answers, it doesn't matter to me, just as long as you have them, okay? All right, little easy. I promise this is easy word problem. And then we're going to do a, test problem and talk about standardized testing for a hot minute. Square, let's draw a square. Remember, square has all 4 congruent sides. I can't guarantee these are all the same, but I tried. And all the angles are what type of angles? Yep. Yeah. Here we go. Okay. What is the length of the diagonal? All right. Okay. Well, diagonal. Doesn't matter which diagonal, meaning I could draw this guy in or this one. They're going to be the same. Doesn't matter. Just draw them in. So we're going to find this. Well, I think we can do this with really hardly any work here. Because if you're cutting it in half, you're splitting this right angle. So these are 45s. And remember, it tells you in the directions of the problem, the side lengths of the square are 7. So you have your 2 congruent sides. I don't even have to do any work. What's your hypotenuse? 7 what? Done. I like that one. That was nice and easy. I'm all about easy. Okay. Standardized. Okay. Now, remember, in the spring, you were taking standardized testing, obviously. That's why you're going to start seeing some of these problems on here. Remember, my hope is, I want to keep you out of STP math next year. Have you heard of STP math? So if you don't get a certain score on this test in the spring, they make you take an extra semester-long class of math next year called Standardized Test Prep Math, where all you do is practice standardized test type of questions. It's really fun. Okay, this is, I swear, an easy, super easy problem. There's no work needed. We just got to read it and pick out the equation. Television with a price of $300 is to be purchased. Okay, they all equal 300. That's not narrowing it down with me. Initial payment is 60. Okay, all right. So I'm thinking B and D are maybe out. And weekly payments of 30. Which of the following equations can be used to find the number of weekly payments W required to complete the purchase, assuming there's no taxes or fee? So you're paying $60 up front, and then you're going to do weekly payments of 30. Question for you. The weekly payments of 30, are you adding those or subtracting those? You're gonna add those, okay? So right away, I'm like, So I feel pretty confident it's what answer? C. You're starting with the $60, you're adding $30 a week. Now, do you know how many times this question? That's so easy. We didn't even have to do anything. But kids see how wordy it is, and I get it. I teach math because I like numbers, and they just are like, "Oh, I'm just going to Hail Mary it and pick an answer because you don't want to read it." They're very, very simple if you read them.